Chapter 3. Terminal. Drawing output. Drawing game graphics on our screen with a terminal. Let's consider what we are going to do. Our game is supposed to look something like the picture above here. So we must figure out how to draw that. What is it? Well, it's a grid of letters, so-called characters, and they're colored. So we have to draw colored letters in a grid. And it looks like we're drawing their backgrounds in various colors as well. This approach does not come out of the blue. Roguelike games used to be played on so-called text terminals, named so because they could not draw proper graphics. From this legacy, we talk of drawing to a terminal, and we will code ourselves a terminal interface, which we will affectionately name term. Our terminal interface will be brief, and it will look something like this. It will have a width and height dimension holding the number of cells on each side of the grid. It will have a method called add for setting a given character cell at a given x and y coordinate within those dimensions with a given foreground and background color, and allowing ourselves a bit of luxury. It will also have a method text that works like add, but prints a whole text string. We can place such an interface in the file source 1 term 3 term interface, and it would look like this. The T-point is a helper class for the term interface. We will put it in its own file, T.ts. It denotes any point on the terminal surface. However, in add and text, we will just use direct X and Y instead of T-point, as this is more practical for us. We then implement the terminal. We're going to add a class term to 3term ts. And we'll begin by making the text and the add methods. So the text method is going to look like this. And it works by delegating to add to draw each single letter in that string to be printed. And add will then, it will look like this. The details here are not important to understand precisely. In the roguelike context, of course, they must still work. The salient points are fill rect here will draw a square or rectangle in the fill color style of BG or background color. Fill text right here draws the specified letter char on top of that square in the foreground FG color. And the path clip rect thing restricts the drawn text to not draw outside the colored square into the neighboring squares. There was a bit of cheating here again. We will need that CTX and the H side and V side stuff from somewhere. The CTX, which we get from here. The CTX is a drawing context for the HTML canvas, and the side variables are the sizes of the square letters tiles we draw. So with the final parts, the class terminal will look like this. It will have a CTX and stuff, and then a method for initializing the canvas. To test our canvas, now it would be nice to see all the code run and do something. We'll need some code to use and exercise our terminal. We can use this class test terminal3.ts. You can go with the test method, which is very simple if you're in a hurry, or you can use the test2 method if you want some payoff. Finally, we'll need an index3 drawTerminal.ts entry point to run it all, like this. Remember to update the entry setting in your Webpack config file from index2 to index3 drawTerm. Then you can run npm start. Alternatively, you may pass the desired entry point directly to the Webpack command as an argument, like this. That will be this one. It won't be visible here. The npx Webpack serve. Adding automatic resizing. This we have so far is pretty much all we need. Its main defect is that it does not resize, so let's fix that. We'll create a new term class called resizing term, which will build on term and extend it with some features. We'll put this into 03 resizing term.ts, which is here. Note that this split up into two classes using inheritance was artificial. It has allowed us to examine drawing and now resizing as two separate isolated features. Normally, the methods of both term and resizing term would just go into a single class. We are now about to create a new index03 resize.ts entry point to try out our resize. And beware that from now on, we will regularly create a fresh index n plus run entry point to try out new features as we introduce them. Whenever this happens, you must either update the entry in Webpack config or specify it explicitly when you run npm, like this: npx webpack serve open entry, and then the name of the entry point file. We hook up our resizing to the browser window's resize event, the jQuery, and index03 resize.ts will look like this. And voila! Now our terminal adjusts its tile size to fit its dimensions inside the current window borders. This involves a compromise with empty borders, as the window may be either too wide or too tall for the tile grid dimensions we have specified to 32 × 16. And trust me, you would not want the terminal to stretch or squeeze your font letters wide or narrow to fit your window. We are pleased that we got this resizing feature added, because without it, our terminal had a so rigid size that it would never even respect the grid dimensions we specified for what term, let alone resize the cell glyph font.